Hello friends, welcome back. Today we'll see convolution sum. We have already seen one video on convolution integral. It was for continuous time systems, continuous time signals, and it is I'm showing here is a discrete time signal, and for discrete time signal we refer to the convolution as convolution sum. Okay, so these both are very similar, just the difference is in continuous time and discrete time, nothing else. But I've decided to make a separate video just as to revise the same concept again. So repetition is very good for memorizing the concepts. Okay, so let us see. An LTI system is taken here. So LTI is linear time invariant system. So what is linearity? Linearity when the system follows property of scaling and additivity. Okay, so what is scaling? So if I scale input x of n by a constant a, then the output which is produced is a y of n. Okay, so this is scaling when the same scaling factors appears at the output. Okay, now what is additivity? If I take several inputs, a1 x1 of n plus a2 x2 of n, okay, plus and so on, I'm taking only 2 here. So it will produce as a total it will produce a1 y1 of n, a2 y2 of n. So sum of all the individual outputs it is producing. So it is following additivity property. So these both properties together, if a system follows, then we can say that the system is following the principle of superposition and it is linear. Okay. Now we'll see time invariance. If I give input to the system which is somewhat delayed by a constant n0, then the output to the system is y of n minus n0. The output is y of n minus n0, that is delayed by same amount. Okay, so this is how these properties are. Okay, so here we are trying to find out how the output is calculated when some specific input is given. So whatever is the relationship between this y of n and input x of n, which is wholly dependent on what is the characteristic of this LTI system. So easiest way to find out the characteristic of the LTI system is to give some input which is very simple and known to us. Okay, and whatever the output we'll get, we'll use this for finding out the characteristic of the system. So suppose I'm giving input del of n, which is the simplest signal, impulse signal. So I'll get h of n as the output. So we call it h of n. We call it impulse response of the system because input is impulse and the response of the system to the impulse is impulse response. Okay, so from this we'll try to derive the relationship between y of n and x of n. So let us start. So first a basic thing is when the input is x of n, we're assuming that the output is y of n. Okay, now we'll start with del of n. Okay, when the input is del of n, I'll get h of n as output. Okay, so let us apply one by one the properties. Time invariance. So I'll delay this by k. So h of n minus k will be the output. The output is also delayed by the same amount. Okay, so now we'll apply scaling property. Okay, scaling, we'll scale this by a constant x of k. X of k is the amplitude of x of n. Okay, so del of n minus k, what will happen? The same constant is multiplying the output also. X of k, h of n minus k. Okay, now we'll apply additivity property. Additivity means several such inputs are given, added together. So we'll apply here summation where k is varying from minus infinity to infinity. We'll take all the output inputs like this. X of k, different amplitudes multiplied to different shifts of impulse. Okay, del of n minus k. So at the output we also get summation of all the individual outputs, which is x of k multiplied by del of h of n minus k. Okay, So in the last video, we have seen how to represent x of n in terms of shifted and weighted impulses. Okay. So this is, we can say this is x of n. Okay. So x of n, any signal which can be represented by the shifted impulses which are weighted by the amplitudes of the signal x of n, it can be represented like this. So if this side is x of n, then the other side is, obviously we can call it y of n. So here how we get the formula for y of n. So we'll write the formula for y of n. Y of n is equal to summation k varying from minus infinity to infinity x of k h of n minus k. Okay, and this also can be written in terms of x of n. This is a form sign for convolution h of n. Okay, so x of n and y of n are related to each other with this formula, which is called as convolution sum. This is the formula for convolution sum. Using this, you can find out y of n with the values of x of n and h of n using this formula. So by this is the relationship of convolution sum. So this is very similar to convolution integral, but the signals used here are discrete time. Okay, so you have seen like this. You are given one input and the system response of the system, and you are asked to find out y of n. So you can use this formula for convolution sum. So we'll see examples how to find y of n from the given inputs, x of n in the system impulse response, h of n, and also see the properties for convolution sum, convolution properties. Thank you.